Students, today we are going to discuss about differential equations. Differential equations plays an important role in every subject of engineering. Differential equation, what is meant by differential equation? So differential equation is an equation differential equation is an equation. It involves two variables. One is a dependent variable and independent variable and its derivatives. Example, you observe dy by dx plus y equal to e to the power of x. D square y by dx square plus 2 into dy by dx plus y equal to sin x. Okay. So it is an equation. Observe here, it is an equation containing dy by dx. So derivative of y with respect to x. So y depends on x and hence x is an independent. So that here we are having two variables. Those two variables are, one is a dependent variable and second one is independent variable. And similarly here you observe d square y by dx square and dy by dx and so on. Okay. So derivative of y with respect to x, derivative of y with respect to x. So it is an equation involving two variables, dependent variable and independent variable and its derivatives. Okay. So y is dependent variable and x is independent variable. So the equation is called differential equation. Differential equation. So the definition of differential equation is, so it is an equation involving independent variables, dependent variables and its derivatives. Okay. Next, what type of differential equations are we are having? So this is, you observe y depends on x, derivative of dy by dx, derivative of dy by dx. So one dependent variable and one independent variable here. So here also one dependent variable and one independent variable. So that one dependent and one independent variable, the differential equations are called ordinary differential equations. Okay. Suppose the dependent variable is 1 and independent variables are 1 or more, 2 or 1 or more. That is dou square z by dou x dou y equal to dou square z by dou x square. Again you observe dou square z by dou x square plus 2 into dou square z by dou y square equal to some z square, like that. Okay. So you observe, so dou square z by dou x dou y, dou square z by dou x square, dou square z by dou x square, dou square z by dou y square. So here you observe z. So dependent variable, but independent variables are more, x y. So suppose you observe dou q z by dou x dou y dou t plus 3 into dou square z by dou x dou t equal to some sin t. Okay. So dou square z by dou x dou y dou t. So z is dependent variable and x, y, z are independent variables. So that the differential equation having one dependent variable and one or more dependent variables are called partial differential equations. Partial differential equations. So that differential equations are classified into two types. One is ordinary differential equations involving one dependent variable and one dependent variable. And similarly, partial differential equation is an equation involving one dependent variable and one or more independent variables are called partial differential equations. And also you observe here, so its derivative is, highest derivative is dy by dx, one time derivative. So also observe here d square y by dx square, so 2 times derivative. And also observe here dou square z by dou x dou y, so z 2 times derivative. Okay, z 2 times derivative. So here is z 3 times derivative. So you observe the highest derivative in this model is 1. The highest derivative in this model is 2. The highest derivative in this model is 2, and the highest model in this model is 3. So that you observe the highest derivative of the differential equation is nothing but called order, order of the differential equation. Okay, so again you observe the highest derivative power, so 1, the highest derivative power 1, the highest derivative power, okay. So again you observe the highest derivative power is 1, the highest derivative power is 1. So the highest derivative power is 1 means the power of highest derivative is nothing but called degree. So here degree is 1. So this differential equation is first order first degree differential equation. This differential equation is first order second order first degree differential equation, second order first degree differential equation. So that the order and degree of a differential equation is defined by the highest derivative. The highest derivative is nothing but called order. The highest power of highest derivative is nothing but called degree of the differential equation. Next, how the differential equations are obtained. Now you observe, by taking a curve, any curve, so the differential equations are obtained by eliminating arbitrary constants. Take an example, y equal to a e power 2x, b e power 3x plus c e power x. Okay, a, b, c are three arbitrary constants. So we need to eliminate a, b, c using 3 times derivative. So differentiate with respect to x on both sides. Okay, so dy by dx equal to a into 2 times e power 2x and b into 3 times e to the power of 3x and c into e to the power of x. Okay, again you observe a e power 2x, b e power 3x and c e power x equal to y. So you write dy by dx equal to y dash is equal to a into e to the power of 2x and b into e power 3x and c into e power x, and remaining terms are already one a e power 2x is used, so remaining term is a into e to the power of 2x and already one time is used here, so 2 times b e to the power of 3x. Okay, this is nothing but y. So y dash equal to y plus a into e power 2x plus 2b e power 3x. Okay, so this is 1 and it is 2. It is 2. And again differentiate with respect to x on both sides. Clear? So again dy by double dash equal to y dash plus a into 2 times e power 2x plus 2b into 3 times e power 3x. Okay, again you observe it is equal to y dash plus, so both the cases 2 common and a into e power 2x and 6 already 2 times 2b e to the power of 3x. Okay, 2 times already used and 4 times 4b is used and the remaining is 2b e power 3x. Okay, so this is equal to y dash and a e power 2x plus 2b e power 3x. By equation 2 this value is equal to y dash minus y. Okay, so y dash minus y plus 2b e power 3x. Okay, this is equation number 3. Okay, again, so this is y double dash. Again differentiate with respect to x on both sides. So y triple dash is equal to y double dash plus 2 times y double dash minus 2 times y dash plus 2b 3 times e power bx. Okay, but 2b e power 3x by equation 3 its value is here. Okay, so again simplify y triple dash equal to Okay, this is 3 times y double dash minus 2y dash plus 3 times 2b e power 3x. Okay, so take 2b e power 3x value here. Okay, so equation 4 becomes y triple dash is equal to 3 times y double dash minus 2 times y dash plus 3 times 2b e power 3x value is this is 2b e power 3x value by equation number 3. This is y double dash minus 3 times y dash 3 times y dash, okay, minus of minus plus 2 times y. Clear? So y triple dash equal to 3 times and 3 times y double dash, so 6 times y double dash. It is minus 2 times and it is minus 9 times, minus 11 times y dash plus 6y. Okay, this is nothing but d square y by dx square d cube y by d cube y by dx cube equal to 6 times d square y by dx square minus 11 dy by dx plus 6y. Okay, so it represents a differential equation, so third order differential equation of degree 1. Okay, so d cube y by dx cube, third order differential equation. So by eliminating a b c, we are having yourself y equal to a x cube and b x square, where a and b are arbitrary constants. And second one, y equal to e power x of capital A cos x, b sin x. Capital A and capital B are arbitrary constants. And the third one is xy equal to capital A e power x and capital B e power minus x, where capital A capital B are arbitrary constants. Okay, try at our homes.